Welcome to Homework Lib.
For this question, we have the generic reaction A goes to B that is found in exercise 1419. Using the data that is there, and also by preparing graphs, it wants you to determine whether the reaction order is first order or second order. As you recall, a first order reaction shows a straight line when you plot the natural log of the concentration versus time. It would be second order if when you plot 1 over the concentration as a function of time, you get a straight line. So this is going to require you to either graph manually or go into Excel and prepare something like this. I chose to go into Excel. I took the data that was provided, the time, and the concentration of A. I then converted the concentration of A into the natural log of the concentration, and additionally converted into 1 over the concentration. Then what you have to do is you'll go into Excel by clicking on Insert and then Graph, and if you choose an XY scatter graph without connecting the data points, you'll get something like what's shown down here. I went ahead and I plotted the concentration as a function of time. I plotted natural log of the concentration as a function of time, and I plotted 1 over the concentration as a function of time. I did concentration as a function of time because there is another common order for which you can determine by simply plotting, and that is zero order. If zero order gives you a straight line, then if the concentration as a function of time gives you a straight line, then it's zero order. So how do we know which one gives us a straight line? They all look pretty good. These data seem to follow a straight line, these data seem to follow a straight line, and these data seem to follow a straight line. Well, if when you're in Excel, you right-click and you go to Add Trend Line, then it's going to attempt to do a linear regression and show you an equation. They show you a line that best fits your data. Then once you have added the trend line, you can modify the trend line by including the equation of the line and what's called the R-squared value. The R-squared value is a statistical value that tells you how well the equation of the line best fits your data. The closer the R-squared value is to 1, then the better the data fits the line, meaning the better the straight line you get from the data. So here we have an R-squared value of 0.942. Here we have an R-squared value of 0.886. And here we have an R-squared value of 0.9997. So the best straight line is coming from the plot of 1 over the concentration as a function of time. Because the best straight line comes from 1 over the concentration as a function of time, this is a second order reaction. Part B then asks you to determine what is the rate constant for this reaction. Well, if it is a second order reaction, determining the rate constant is simple so long as you have asked Excel to show the equation of the line. The rate constant, when you have the equation of the line, is simply the slope. So in this case, the K value is 0.0419, and because it's second order, the units are going to be 1 over molarity time, and the time units are minutes. I put seconds up here, but the time units are actually minutes. Next it asks, what is the half-life for the reaction? Well, as you recall, the half-life equation for a second order reaction is T1/2 equals 1 over K multiplied by the initial concentration. So if we want to know the first half-life, although it doesn't ask, it simply says what is the half-life. The half-life changes for second order reactions. We will assume it is asking for the first half-life. So that means we will use the initial concentration of, in this case, 0.65. Now I know that the data in the problem for 1419 gives a number of 0.065. However, as you recall, this was just the moles. If you take the 0.065 and you divide it by the 0.1 liters, the 100 milliliters, you will get the concentration of 0.65, and you'll get all the concentrations when you do that for all of the times. Essentially, we're moving the decimal place one spot to the right. So if we take this as our initial concentration and we take the K value we determined from the slope of the line, we can calculate the first half-life for this reaction, which in this case is 36.7 minutes.